All right, so my first video, I introduced the theory of everything, which is that the universe is a big ass fractal. My second video, I explained what's dark matter. In this third video, we're going to cover dark energy. And if you're thinking that we're running out of mysteries, we're not. There's still a lot to learn with this theory, so buckle up. I am going to give a content warning. If you're a big banger, you need to make sure that you have tissues and a puke bowl because you're not going to like this video. You might want to change it. To understand dark energy, you first need to understand the timeline of events. So, first, it was discovered that a lot of the galaxies were redshifted. There's no known two atoms that have two fingerprints that are only a shifted difference apart. So, the conclusion there is that the entire spectrum was shifted. The Doppler effect was proposed as the reason, although it didn't quite fit light because light itself is a particle and the wavelength of light is intrinsic to the particle. While in a real Doppler effect, you actually need many different pressure waves to really reproduce it, and that doesn't describe how light works. The relativistic Doppler effect works similarly to the regular Doppler effect. It works by a similar principle, except it uses relativity to describe why there's redshifting and blueshifting. So the Big Bang Theory originates from this idea then that everything is just moving further away from us in all directions. Alright, so let's start making a list of what dark energy might be, and it could be that there's many factors. So first off, let's add relativistic Doppler effect. Another theory that gets floated from time to time is the idea of tired light. So, what's going on here is that maybe the universe is not expanding, but instead, light is simply losing energy as it propagates through space time. So, then by the time it gets to you, it is weaker, and that causes its wavelength to get longer, and voila, redshift. Let's try things in the simulator and see if maybe we can observe anything that might also suggest a method of redshifting. So we can see that as this light, which is kind of string-like apparently, moves through what I would describe as a tunnel, it starts to increase its wavelength and eventually falls apart. Let's go ahead and add that to the list. I know I've gotten light to be stable, so let's try to see if we can recreate that. Let's go ahead and increase the pressure of space-time and try creating channels. By creating channels, I'm emulating the fact that our star is sending light in the galaxy's direction, and the galaxy is sending light in our direction. We can see that it's substantially more stable this way. What if we mimic space-time pressure decreasing as you move away from the galaxy that you came from and move towards the galaxy that you're going to? The space between galaxies would presumably have much lower space-time pressure. Based on what I'm observing, it would appear that as space-time pressure drops, these waves get more spread out and are more likely to diverge and leave. So it's both stretching and losing energy. So I guess let's add that to our list. Oh wait, are we sure there's this tunneling field thing happening between galaxies? Yeah, I'm pretty sure. Another possible cause of redshifting would come from shedding. Shedding is one of the subdivision mechanisms. And basically, what I'm theorizing is that as energy sheds, it becomes more attuned to the field that it's in. And as a result, you essentially have energy lose energy until it fits the tunnel it's in and stays there. So let's add shedding energy to our list. So then that brings up a really good point, which is that, hey, wait a second, dark energy is called dark energy not because of the redshifting, it's because of what the redshifting implies. And so the question is, why is there energy causing the universe to expand using the Big Bang Theory? And didn't we just describe a mechanism there where we have energy going through it and the energy shedding it and the shedding's getting left behind to create the structure of space-time? And then likewise, using the fractal theory, isn't energy displacing space-time? So in theory, if you're leaving behind more and more energy as you go, you would be expanding? Isn't that where this dark energy is coming from? And the answer is yeah, kind of, but we're still not done yet. Another thing we haven't addressed is that the implications of the redshifting is that the universe is expanding at an accelerating rate. Well, one thing you can consider is that if you were shrinking, then you would think that the universe is expanding faster, even if you're shrinking at a set rate. And this graph demonstrates that. Let's look at a couple ways light could be redshifted due to shrinking from the subdivision process. First, the theory and simulation behavior suggests that shrinking would be faster around mass. So light, traveling between two galaxies, would experience less mass and shrink less. The resulting wavelength would thus be longer. Secondly, if you shrink, your ruler shrinks with you. So when you measure distance with that ruler, things seem to accelerate away, which is what that previous graph was demonstrating. All right, let's add another thing to the list. All right, that's got to be it, right? This is a lot. We don't need any more. Why is there a space like there's one more item? Oh, come on. So, remember that so-called Einstein ring from the last video? And yeah, if we're in one of the blue shifted regions like you see here, then recall that if this is not an Einstein ring, that would indicate that that means the space-time is relatively compressed. Then everything outside of our region would appear redshifted. All right, so I'm calling it at 7 reasons. There might be more, but whatever. The point is that there's a lot. We might be able to reduce it down. I think items 1 through 3 are actually like the same thing. It's admittedly a different kind of tired light than what the original theory called for, but I would say at the end of the day, I would still describe it as tired light. 4 and 5 are both related to changes in space-time pressure. So those two are also very similar. Number 7 may or may not be true. If it is, it's definitely a confounding factor. All right, so where am I going with all this? The answer is that there are a ton of reasons that something could be redshifted, not just one reason. And that's really important because the Big Bang Theory kind of is built on this whole thing. And the whole reason dark energy is a mystery is because it assumes that theory is correct. So when you see a very young, very far away, very large, very established galaxy, it may not be young, nor far away, nor relatively large. Thanks for watching. Please, I hate reminding this, but like and subscribe. And yeah, so in some future videos, I'm going to be looking at some pretty scary stuff that honestly kind of creeps me out. Take a sneak peek. So this is UFO footage that was declassified. And after giving it a couple looks, I understand why they declassified it. I don't think they understand what it is. And I'm going to see if I can try to explain what we're seeing based off of what I've learned through researching this theory. Hey, that's the same last name as me, but I'm not them. So this other thing I'll be looking into is what is going on with the Hutchison effect. A lot of weird stuff, and unfortunately, very hard to reproduce, apparently.